examples related to this probability chapters, right? You may have learned many such examples in your school. Let me write another one that may help you a little bit. So related to the some coin, right? Related to some coin. Suppose it's a coin, right? And this is head person, and the same coins it's tail person, right? Now this head person and tail person, keep these things in mind, right? This is a tail person. Now I'm just tossing this, right? I just flip this coin. So what is the probability that I will get the head? What is the probability that I will get the head? So there are actually two faces. One is head and another is tail. There are two faces. Out of these two faces, what is the probability that I will get the head only, not tail, right? So first, how many faces are head? Of course, there is only one face in a coin, that's head, and total faces, that's two. So favorable faces is 1 and the total faces is 2. So the probability of getting head, right, is 1 upon 2, or we can simply say it's 50% also, or if you want to represent it in decimal form, then it will be 0.5, right? So you can represent in any way whatever you like, right? So again, in the same problem, if anybody asks what is the probability of getting tail, then what you will say? The probability of getting tail is again, so the total number of tail, total number of the faces of the tail, that's 1, and the total faces are 1 and 2, that is 2. So 1 upon 2, that's the probability of getting tail, right? The last example, let me give you, it's going to be a longer, right? So I cannot make a very long video in YouTube. So let me make a dice here that we used to play, die, right? That's called die, not dice, simply, right? Mm, in child, I used to play a lot of Ludo games, Ludo board game, right? You might have played this. Now, let me color this part. It will look better, right? And this part also. So it's a die that we generally play in a Ludo board game, right? Right? And there are 6 faces. Actually, it's a perfect cube, right? So in that die, you might have seen, right? You might have played the game. There is written uh, the words, or there may be the dots also. It's 1, right? This is 1, this is 2, right? This is 3, and again there are 6 faces, so here it will be 4, 5, 6. So altogether there are 6 faces, right? And first one, 1, 2, 3, 4, 5 and 6, these all are the 6 faces, and in each face there is written this, every faces there will be written somewhere 1, somewhere 2, somewhere 3, 4 and 5 and 6. In all faces there is written these words, right? In one face there will be only one particular these things. You might have seen this, right? I don't want to talk about this more, right? So now you're just throwing this die, right? And when you throw this die, what is the probability that you will get some odd number, right? Some odd number. What is the probability that you will get some odd number? So how to calculate this, or how to find the probability of getting the odd number when you throw a die, right? So first, how many odd numbers are there? How many cases in which we get the odd number? That we need to find out, right? So there are 1 to 6 numbers, and the odd numbers are 1, 3 and 5. So the cases of getting odd number is 1, 2 and 3. Means there are 3 cases that we will get the odd number, and the total cases here are 1, 2, 3, 4, 5 and 6. So this is the probability of getting odd number when you throw a die, right? So another question it may be like, what is the probability of getting an even number, right? What is the probability of getting an even number? So again, see how many even numbers are there first. 2 is an even number, 4 is an even number, 6 is an even number. So there are again 3 even numbers, right? So the cases that will get the even number when we throw a dice are 3, and the total numbers or total cases is 6. So the probability of getting the even number when we throw a die is 3 upon 6, or you can simply, if you calculate it, it will be 1 by 2, 1 by 2, or you can simply say it's 50%, 50%, or you may say it's 0.5%, 0.5, 0.5, right? So this is exactly how we calculate the probability, right? But one thing, what you have seen, friend, everywhere we get the probability when we convert these all between 0 to 1 only. Here is 0.5, here is 0.5, right? Here is also 0.5, right? Here is also 1.5, that's 0.02, right? uh, so in all cases, here 3 upon 10, that's 0.3, right? so So in all cases, we get the value of the probability of any events, right? Probability of any events, right, is always greater than the 0, right? Or sorry, greater than the 0 or maybe equals to the 0, and less than and equal to 1. So probability, right? Let me write here with the different color, that probability of anything happening, probability of happening anything is always less than and equal to 1, right, but greater than and equal to 0. If the probability is 0, it means never ever it will happen, it will not happen ever, right? Probability never, it's called never, never it will happen. If something has the probability 0, it means never it will happen. And if it is 1, it means sure, certain, right? Sure, certain, we can say 100%, 100% it will happen, right? It's 100% it will happening, it's a sure cases, right? Just like uh, Thursday is followed by the Wednesday, that's the 100%, right? Every time we know that the after Wednesday Thursday comes. And never happening, just like Saturday being followed by the Monday, right? Never Saturday followed the Monday, right? So that's never cases, that's uncertain, that's 0%, right? So that's the probability, that probability have the 0%, means the Saturday followed by the Monday, that's exactly the 0% probability. And Wednesday, sorry, Thursday being followed by the Wednesday is the 100% certain, 100% probability, right? That's 1. So I hope you understand a little bit idea about the probability in this chapter. Actually, I went there here in this chapter, in this video, especially in practical approach, right? And in next level of the probability, we'll be solving in some theoretical approach, right? So we'll be meeting in the next video soon. Bye bye.